morning everyone. Today I am going to take a lecture of Discrete Mathematics, chapter number 2, the prepositional logic. And today's topic is examples based on logical connectives, tautology, contradiction, contingency, and the logical identities. Okay, so here we have one example. Construct the truth table for the form negation P tends to R conjunction P by conditional Q. That means what? Here we write here the truth table P, Q and R. Why we use here the P, Q and R? Because of according to your question, we write here the negation P tends to R and the conjunction P by conditional Q. That means what? Here we have the three sentence or three, we can say that the three statement. Okay, so negate P, Q and R. So if we have the only the two sentence or the two tense, so we write here only the P and Q. Okay, and what is the process of according to P and Q? If we use only two sentence, so here we write only P, T, F, F. This is your P. Okay, and Q is equal to TF, TF. But in this example, we have the three statement or sentence P, Q and R. Okay, so if we use the three types of the statement, so we write here, first one is the T, 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 F, 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 F. That means what? Here we write the 4 times T and the 4 times F. Okay, this is your column of the P. Q is equal to what? We write here 2 times T and the 2 times of F. Okay, so T, T, F, F, T, T, F, F. Okay, next one is the small r. So small r just like in the Q, if we are given in the two statement. Okay, so T, F, T, F, T, F and the T, F. Okay, next is according to your question. Always keep in mind your table is defined on according to your question. Okay, because of here we are given in the negation P tends to R. So first we mark the column according to your negation P. Okay, so what is the negation P? P is equal to what? 4 times T and we write here 4 times F. Okay, so negation P, that means we write here 4 times F, 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 F and the 4 times T, 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 T. Okay, next one is we write here the negation P tends to R. So next column is negation P tends to R. So what is the process? Process is that if we find the negation P tends to R, so always keep in mind if your two sentences are true, okay, and two sentences are false, or you can say that two statements are true and the two statements are false, so both are true. Okay, that means negation P tends to R. So first one is the FT. And if your first statement is false and the second is the true, so always you write here according to your second statement. This is very important point. If two statements true and the two statement false, so you write here only the true. Okay, but if your one statement is true and the second statement is false or just opposite, first statement is false and the second statement is true, so you write here the true according to your second statement. Okay, so just like FT, so what is the second statement? T, so we write here T. FF, we write the T. FT, we write here T. FF, T. TT, T. FT, TF is equal to F. TT is equal to T and TF is equal to F. So with the help of this negation P tends to R, so process is that two statements are true, so we write here true, two statements are false, so we write here false, and one statement is true and the second one is false, so we write the false. Okay, and if one statement is false and the second is true, so we write here according to your second statement, you write here the true. Okay, next one is according to your question, we write here the P by conditional Q. Okay, so we have here the P and Q and we write the by conditional Q. So what is the logic? What is the logic by the by conditional P and Q? Okay, if and only if. So here TT is equal to T, next TT is equal to T, TF is equal to F, TF is stands to F, FT is stands to F, FT stands to F, F tends to T and FF tends to C. So what do you mean? What do you mean by the P biconditional Q? So P biconditional Q, the process is that if you have the two statements are true or two statements are false, so you write here only the true T. But in case your first statement is true and second is false, okay, so you write here the false. But your first statement is false and the second is true, so again you write here the false. That means what? In biconditional, the process is that if your two statements are true or false, so you write here only the true. But if your one statement is true and second is false, so you always write here the false F. Okay, next one is we find here the negation P tends to R and the conjunction P biconditional Q. Okay, so we mark here already two columns, negation P tends to R and the P biconditional Q. So we use here between the conjunction sign. So what is the process of the conjunction sign? If T is equal to T and all the remaining we write here the F. Okay, so here first T is equal to, we write here T, second T is equal to T, TFF, 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 FF is equal to F, T is equal to T and Ft is equal to F. That means what? Here we mark the truth table according to your connectiveness. We use the different types of the connectives, conjunction, if and then, if and only if, negation P. So here according to your conjunction, the process is that if your two statements is true, so you write here true, otherwise all the remaining you write here the false. Okay, next one is the tautology. What is the meaning of the tautology? The tautology is a propositions which is true for all truth values of its proposition. That means what? If we have a truth table and according to truth table your final answer all the values are true, so you can say that this is a tautology. Okay, in other words, a proposition is a tautology if it is true for all assignments of the truth values. Okay, next one is the contradiction. So a proposition is a contradiction if it is always false for all assignments of the truth values. Okay, that means if your final answer, the table is all these values are true. Okay, so this is your tautology, and if all the values are false, so this is your contradiction. Next one is the contingency. So here a proposition which is neither a tautology nor a contradiction is called a contingency. Okay, next is this is an example and we prove that here this is a tautology. So we are given in the P disjunction negation P. Okay, so what is the truth table? Truth table is first we write the P. Okay, so P is only one sentence, so obviously we consider T and F. Okay, if we have the two sentence, two statement P and Q, so we write here P, T, F, F and Q is equal to what? T, F, T, F. Okay, and in case we have the three statements, so first according to P, you write here 4 times T and 4 times F. Q according to 2 times T, 2 times F and continue this process, and according to R you write here T, F, T, F. Okay, so here first we write the T, so T is equal to, we write here the T, F and here negation P is equal to what? F, T. So P disjunction Q, that means what? If we have two statements are false, that means FF is equal to F and all the remaining statements you write here true. Okay, so T F equal to T and F T equal to T. So what do you mean by here T? That means what? That means if we have the last column is all the values are true, so it is a tautology. So since all the entries in the last column are T, so it is a tautology. Okay, next one is the second example is check whether the P disjunction Q in the bracket and the conjunction negation P tends to Q is a tautology, contradiction or contingency. That means what? In the last column all the values are T, or last column all the values are F, or P and F we have the mixed values. Okay, so here we have the two statements. So always keep in mind, first you check here the given statement. Okay, if you have the three statements, that means P, Q and R, so according to this you write here total each conditions. Okay, so first we write here the P and Q. Okay, so P, T, T, F, F, Q, T, F, T, F. So negation P is equal to what? Negation P is according to P is T, T, F, F. So negation P is F, F and T, T. Okay, next one is the P disjunction Q. So what is the process for finding the disjunction? So if we have FF, two statements are false, so you write here the true. Okay, and all the remaining rest of all the values you write here the T. Okay, so FF is equal to F and all the remaining you write here the T. Okay, so P disjunction Q, TT is equal to T, TF is equal to T, FT is equal to T, but FF is equal to F. This is your P disjunction Q. Next one is the P disjunction Q in the bracket conjunction negation P. That means what? We use the conjunction connectives, but which of these two values? The P disjunction Q and the negation P. So what is the process of the conjunction? The conjunction, if two statements are true, so you write here true, otherwise you write here F. Okay, so here your fourth column and the third column. Okay, so T, F, F, T, F, F, but we have T, T, so we write here the T. Okay, and next one is F, T is equal to F. So last one is what? Last one is according to your question, P disjunction Q in the bracket, we write here the conjunction negation P tends to Q. Okay, so here this is your fifth column and your second column. Okay, so FT is equal to T, FF is equal to T, TT is equal to T and FF is equal to T. So what is the logic? Logic is that if you have the if and then conditions, so if two statements are true or two statements are false, so you write here the true value, otherwise you write here according to your second statement. Okay, that means second statement is false, so you write here the false, and the second statement is true, so you write here the true value. Okay, so according to your last column, all the values or all the entries is the true, so this is a tautology. That means since all the entries in the last column are T, so it is a tautology. Okay, next one is check whether the question is P conjunction Q, this conjunction negation P disjunction Q, it is a tautology or contradiction or contingency. Okay, so with the help of truth table, we find very easily this is a T values or F values or the T and F both the values. Okay, so first of all, you check here the total number of statements. Okay, so here we have the two statements P and Q. So first you write the P. So what is the P? T, T, F, F. Q, T, F, T, F. Next is P conjunction Q. So what is the definition of the P conjunction Q? What is the process? Process is that T, T is equal to T and remaining all these terms we write here the false. Okay, so T, T is equal to T, T, F is equal to F, F, T equal to F and F, F is equal to F. Next one is the P disjunction Q. So P disjunction Q, that means what? FF is equal to F and all the remainings you write here the T. Okay, so here TT is equal to T, TF equal to T, FT is equal to T and FF is equal to F. Next one is the negation P disjunction Q. Okay, so here the negation P disjunction Q, that means what? We have the P disjunction Q column, okay, and according to this column you write here the negation sign. So what is the meaning? Meaning is that the T, the negation is F, T, F, T, F and F, T. Okay, so your last column is what? Last column is P conjunction Q, conjunction negation P disjunction Q. Okay, so we have the P conjunction Q column Okay, next one is we have the P disjunction Q column according to your negation sign. Okay, so according to third and the fifth column, you find out the table. So your third and fifth column is what? TF, obviously F, FF is equal to F, FF is equal to F, and FT is equal to F. Okay, so since all the entries in the last column are false or F, so it is a contradiction. Okay, so next one is the logical equivalence. So what do you mean by the logical equivalence? So two prepositions are said to be logical equivalent if and only if they have the same truth values for every choice of truth values of prepositions involved. Okay, so it is denoted by P equivalence Q, and provided P and Q are the prepositions. So in other words, two prepositions P and Q are logically equivalent if and only if P biconditional Q is a tautology. Okay, so here this is a table. Prove that the truth table is P disjunction Q conjunction negation P equivalence to what? Negation P conjunction Q. So truth table, first we make the truth table. So we write here PQ. P is T T F F. Q is T F T F. Negation P is F F T T. And the P disjunction Q, that means what? If we have two statements are false, so you write here the false. All the remaining you write here the T. Okay. So FF is equal to F, and all this remaining we write TT is equal to T, TF is equal to T, FT is equal to T, and FF is equal to F. Okay, next one is the P disjunction Q conjunction negation P. Okay, so here first we write here the LHS column because we find out the equivalent sign. So if both the LHS and RHS we have the same table, so or same values, so we can say that the P and Q, both the statements are equivalent. Okay, so here P disjunction Q conjunction negation P, that means we have the fourth column and the third column, and we find out the conjunction. So what is the process? Process is that in the conjunction, if we have two statements is true, okay, so we write here true. Otherwise, all the remaining you write here the false. Okay, so here P conjunction Q disjunction Q conjunction negation P, that means TF equal to F, FT, TF equal to F, TT is equal to T, and TF is equal to F. Okay, next one is we find out the right hand side, that means negation P conjunction Q. Okay, so negation P conjunction Q, that means we have the third and the second column, negation P conjunction Q. So what is the process? In the process, if you use the conjunction sign, so if your two statements are true, so you write here true. Otherwise, all the values you write here the false. Okay. So here in the third and the second column, FT is equal to F, FF is equal to F, TT is equal to T, and TF is equal to F. Okay, so according to your fifth and the sixth columns, last two columns, all these values are same. FFTA, FFTA. Okay, so here the entries in the last two columns are same, and it is true that P and Q, both the statements are equivalent. Next one is the duality law. So what is the duality law? Two formulas are said to be dual of each other if either one can be obtained by the other by replacing disjunction by conjunction or vice versa. Okay, that means the connectives disjunction and the conjunction are called duals of each other. Okay, so here we have some formulas, the logical identities. First one is the De Morgan's law. Okay, so according to De Morgan's law, the negation P disjunction Q equivalent to negation P conjunction negation Q. Okay, that means your disjunction sign converted into the conjunction sign. Okay, next is the negation P conjunction Q equivalent to negation P disjunction negation Q. Next one is the associative law. So P disjunction Q disjunction R equivalent to P disjunction Q in first bracket disjunction R. Next is the P conjunction Q conjunction R equivalent to P conjunction Q conjunction R. This is our associative law. Next one is the commutative law. So here P disjunction Q equivalent to Q disjunction P and P conjunction Q equivalent to Q conjunction P. Next one is the distributive law. So P disjunction Q conjunction R just like the union and the intersection sign. Okay, so equivalent to in the outside of your connectives you write here in the inside, and according to your inside you write here the outside from the bracket. Okay, so here P disjunction Q in first bracket, according to we write here the conjunction sign, and next is the P disjunction R. Next is the P conjunction Q disjunction R. That means what? We write here P conjunction Q. According to your formula, you write here the disjunction sign. After that, you write here the P conjunction R. Okay. Next is the idempotence law. So here P disjunction P equivalent to P and P conjunction P equivalent to P. Next is the absorption law. Here P disjunction P conjunction Q equivalent to P and P conjunction P disjunction Q equivalent to P. Okay, next one is the double negation law. So negation P equivalent to P. Okay, so this is your example proof De Morgan's law. That means negation P disjunction Q equivalent to negation P conjunction negation Q. Okay, so we have here P and Q. We write here T T F F Q T F T F negation P F F T T negation Q F T F T. P disjunction Q, that means what? If two statements are false, so you write here false, otherwise you write here the true. Okay, so here we write P disjunction Q T T T F F. Okay, and the negation P disjunction Q, that means what? F F F T. Obviously the P disjunction Q T T T F, so negation is F F F G. Okay, and the last is the negation P conjunction negation Q. So we have the third and the fourth column. Conjunction, that means what? So always keep in mind, you write remember that the only one sentence, so you write here very easily what is the meaning of the conjunction and the disjunction and the biconditional and if and then tends to. Okay, so here negation P conjunction negation Q. So what is the process for the conjunction? If two statements are true, so you write here true. Okay, and all the remaining you write here the false. So FF equal to F, FT equal to F, TF equal to F, and PP is equal to P. So see here your last two columns FFFT, FFFT equal. Okay, so here the entries in the last two columns are same, hence it is proved. Okay, so I will continue this topic in our next lecture. Thank you for watching this video.